And hi again, it's Dennis Hudson for the Hudson Equilibrator, U.S. patent number 8591449B2. And this time I'm assuming that you have already watched the primary how it works video, and we don't need to cover that. So in this video, which I hope to keep under about 2 minutes, I plan to show you about 4, maybe 5 different ways to use the device in an aerospace application. And thank you again for joining me for this short video. Okay, first up is landing gear. Now, I'm not an aeronautical engineer, but my understanding of how a landing gear properly works is to prevent the aircraft on landing from bouncing too high back up and being even lifted, the wheels being lifted off the ground. And of course, I'm aware that you already have very sophisticated systems for achieving that goal. This just makes it better. Now, in your present system, the way it normally works is after the initial shock, the shock absorption system and spring begin to separate the plane and the wheel. In other words, to normalize the distance between them. But the initial force that's involved in doing that is initially very large, and it tapers off and gets less and less as the plane rises away from the wheel. And of course, there's nothing wrong with that at all. In fact, it's ingenious. But what we do here with the Equilibrator is that initial return is at a single force. That force doesn't change. It's not very large at the beginning and then small at the end. It is a constant, and that's the difference between these two systems, and this makes it better. Okay, we just crossed the 2-minute mark, and I'm hurrying because I value your time. First thing here is a lubricating pump. This is where you would load it with a lubricant, a grease or whatever, and you deliver it at a constant rate. That would be very important for parts that rub together. Then there's the idea of a fuel pump, and you would need 2 of these actually. One that's discharging to the engines while the other is loading fuel either by gravity or by a secondary pump. And I should point out that this type of fuel pump has a special advantage in high-performance aircraft, because as a high-performance aircraft turns and spins, a normal fuel pump might be wondering where its next drop of fuel is coming from as fuel sloshes around in a tank. Not that your tanks slosh, but this is one way of making sure that they don't slosh. Fuel is there when the engine needs it and when you want it. And finally, rocket motors. This is where you combine oxidizer and fuel into a single pump, and it comes out at a predetermined proportion at a predetermined rate. And that's about all there is. I think I just ran into like 3 minutes and 24 seconds. And thanks again for viewing this. I hope to hear from you soon. I'm Dennis Hudson. And by the way, that oxidizer fuel combination is 2 separate bags. I may not have explained that. That's 2 separate bags.